In week 8, we continued our conversation about the properties by looking at the order in which we divide numbers. If we recall, the order in which we multiply numbers did not matter, and that was the commutative property of multiplication. So 5 times 7 is equal to 7 times 5. 35 is equal to 35, and that's the commutative, allowing me to move the numbers around multiplication, property of multiplication. Now when we look at division, we say, is 5 divided by 7 the same as 7 divided by 5, or equal to 7 divided by 5? Here, 5 divided by 7, we could represent it as a fraction, 5/7, and 7 divided by 5, we could represent as a fraction, 7 over 5. And we see that 5 over 7 is not equal to 7 over 5. 5 over 7 is actually less than 1, called a proper fraction, because the numerator is greater than the denominator, and 7 over 5 is actually greater than 1, known as an improper fraction, because the numerator is greater than the denominator. Now, 5 over 7 and 7 over 5 are reciprocals of each other. That's the word we use to describe when you flip a fraction. So here, 5 over 7, if we flip it over, we get 7 over 5. Now, reciprocals should not be confused with opposites. So here we have opposites on opposite ends of 0. Reciprocals, 5 and 1/5, are actually on the same end of 0. So these are reciprocals. Okay? But these are opposites. Okay, so opposites, opposite ends of 0. Reciprocals are when you flip a fraction, so they are not the same. Now, when you multiply 5 over 7 by 7 over 5, it would be interesting to see what we get. So 5 over 7 times 7 over 5, when we multiply fractions, we multiply the numerator by the numerator and the denominator by the denominator, we get 35 over 35. Now, 35 divided by 35 is 1 whole, and so we want to see what happens when we multiply other numbers by their reciprocal. Now, if we go straight to the generalization, we see that a over b times its reciprocal, b over a, is going to be ab over ab, because I want to write the numbers in order, which is also equal to 1. Okay? So our generalization is that when we multiply a number by its reciprocal, we're going to get 1. Now, when we multiply by 1, we see 5 over 7 times 1 is still 5 over 7. 7 over 5 times 1 is still 7 over 5. And so when we multiply a number by 1, it does not change the value of the number. The first thing we want to look at is multiplying reciprocals. So if when we multiply reciprocals, we always get a result of 1, then we can generalize this idea with a property. So a times its reciprocal, 1 over a, right? We see a over 1 and 1 over a. When we multiply them numerator by numerator and denominator by denominator, we get a divided by a, which is 1. Because we're using multiplication, this has to be a multiplicative property, not to be confused with an additive property using addition. Now, what we are doing is multiplying reciprocals. And another word for reciprocal is a multiplicative inverse. So we get the multiplicative inverse property by multiplying a number by its inverse. The result of that multiplication is 1, and so we say the product of any number and its reciprocal, reciprocal being the multiplicative inverse, is 1. Now, we did notice some things about 1, and so we want to investigate that as well. Now, if it is true that multiplying by 1 does not change the value of the number, then we can generalize this as a property as well. Similar to adding 0, when we multiply by 1, we see a times 1 is going to be a. We get a mirror image after multiplying by 1. Now, the number keeps its identity, and so 1 has to be the identity, and we should specify that it's the identity of multiplication. Because we are using multiplication, just as last time, it is a multiplicative property, and what we are doing is multiplying by the identity of multiplication. So we get the multiplicative identity property. And that says that the product of a number, any number, a, and 1, is going to be that number itself, a. Now, since 1 is the identity of multiplication, we can come back over here, and we can say the product of any number and its reciprocal, or multiplicative inverse, is 1, and we know that 1 is the multiplicative identity. And so we see the product of any number and its reciprocal is the multiplicative identity. In summary, we have the additive inverse property, which is a plus additive inverse is equal to 0. And we have the additive identity property, which is a plus the identity of addition is equal to a. And this thing maintains its identity. If we look over here, we have the multiplicative inverse property, which says a multiplied by its inverse, its multiplicative inverse, is going to give me 1. And we have the multiplicative identity property, which is a multiplied by the identity is equal to a.